In this video, we are going to learn how to configure your pipeline engines for high availability and fault tolerance in Control Hub. High availability means that Control Hub ensures that your jobs are always running. Also, it means that there will be an available engine for your pipeline to use should anything happen to the current engine. Fault tolerance means that your pipeline will automatically restart itself on an available engine if something happens to the current one. For example, in a fault-tolerant design, if one engine is running on a server that loses power, your pipeline will automatically restart a new job on an available engine. Let's take a closer look at the two things you'll need to configure for all pipelines that you want to run in a highly available, fault-tolerant way. Let's call these half pipelines. These two configurations are made at the engine level: failover and engine labels. Failover capabilities engage automatically when an engine fault occurs, and proper labeling is essential for configuring additional engines that are readily available to handle the new pipeline jobs. First, you will need to ensure that failover is enabled on all of your engines. Failover works by restarting a failed job on another available execution engine that is assigned all of the same labels specified for the job, starting from the last saved offset. Failover ensures that a failed pipeline automatically restarts in the following situations. 1. The data collector that is running the pipeline unexpectedly shuts down. 2. The pipeline has reached the maximum number of retry attempts after encountering errors and has transitioned to a start error or run error state. 3. An available data collector has all of the same labels specified for the job and is not currently running an instance of the job. Failover is enabled when creating a job. On the Create Job Instance page, make sure that the Enable Failover checkbox is selected. Next, we'll need to make sure that all engines in our failover environment are properly labeled. Labeling is critical because failover is only allowed on engines with the same labels. In the Engine Labels section, add the labels needed to match the job to your engines. When the job runs and then fails, it will automatically synchronize itself only if the engine has a matching label. You can edit your engine labels by going to the Engines page in Control Hub, clicking on the engine, and then clicking Edit. Here, you can add and delete engine labels. You can also define maximum runtime thresholds for CPU, memory, and pipeline count on this engine. Click Save when you have finished editing. Now that we've seen how halved pipelines work, let's see how both the balance jobs and synchronize jobs functions ensure continued availability. Balancing jobs redistributes the pipeline load across matching engines for a job enabled for failover. For example, you can balance an engine that has 6 running pipelines with another that has 0, so each now runs only 3, balancing out the processing load. When you balance jobs, be aware that only currently running jobs that are enabled for pipeline failover can be balanced. Balancing will stop the running pipeline instance for the job and restart the pipeline from the last saved offset on a matching data collector that has not exceeded any resource thresholds. You can synchronize a job when you change the engine labels while the job is actively running on those engines. Synchronizing jobs stops pipelines on data collectors that no longer match the same labels as the job. Then, starting with the last saved offset, restarts the pipelines on additional data collectors that match the same labels as the job. In Control Hub, you can go to the Job Instances page to see which labels each job has. You can see that in our example, all 3 jobs are running on the data collector that shares the same labels as the jobs. We are going to add a label to an engine that matches our jobs, and then remove this label from the data collector that is currently running the jobs. Finally, we will synchronize all 3 jobs. you can see the jobs automatically stop and restart themselves on the engine that now has matching labels. As always, the StreamSets documentation provides in-depth details on these topics. Navigate to the Job Instances section of the Control Hub documentation to view information for both data collector and transformer pipeline failover. In our next video, we are going to learn about special considerations for transformer engine types when implementing high availability and fault tolerance. We will then look at a comprehensive scenario to demonstrate these concepts in action. Lastly, you will complete a lab exercise to apply these concepts and see them in action yourself. Thanks for watching.